tomorrow will be better. Look at this equation here, and we are asked to find x. Follow me, dear friends. Solution. By experience, you will notice that whenever you have this kind of exponential equation, there are some hints which should guide you on which approach to use. Look at this. This is base 2 raised to a certain power. Now, this is 4. We know that this 4 can be expressed in base 2 as well, and this is the information we are going to explore. So we know that 4 to the power of x can be expressed as 2 first of all squared. This is 4, and then this x here. This can also be expressed as 2 to the power of 2x and multiplying this, which can also be expressed as 2 to the power of x and then raised to the power of 2. Now let me rewrite this equation with this. So I will have, instead of this, I will write 2 to the power of x all squared. Now look at this other term here. 2 to the power of 3 plus x can also be rewritten as, first of all, 2 to the power of 3 times 2 to the power of x. This is in accordance with one of the laws of indices that says the same bases being multiplied, we just add their indices. So this is what we've done here. We've just reversed it. Now, instead of having this 20 to the right side, I'll bring it to the left side. And of course, its sign is going to change. So on the right side, I have nothing left. So it's 0. Now look at something here. This is 2 to the power of x. This is 2 to the power of x. I will introduce another variable here so that I don't have to be carrying 2 to the power of x all along. So I will say let 2 to the power of x here be equal to t. So that now I'm going to have that instead of 2 to the power of x, I'll have t squared plus, what is 2 raised to the power of 3? This is 8. So 8, 2 to the power of x, therefore 8t, and then minus 20 equals to 0. Clearly, I have now a quadratic equation. Once more, you're wondering, what inspired me to introduce this other variable here? This is because from experience, I've noticed that with this and with this, I knew I was going to end up with a 2 or something like this raised to a degree of 2. And the degree 2 polynomials is quadratic equation. So here we go. Now, whichever method you want to solve this is up to you. But if you correctly do this, you will have 2 solutions of t. T will either be equal to negative 10 or equal to 2. Now, but don't forget that our t is actually 2 to the power of x. So I will say 2 to the power of x for this first solution equals to negative 10. You will notice that there is no value in the domain of real numbers, which if you substitute here for x will give you this. So this has no real solution. But for the second solution, 2 to the power of x equal to 2, which can also be written as 2 to the power of 1. So now that they have the same basis, we will compare